Hello children, back again with a new chapter, alternating current, chapter 7 in your NCERT book. Alternating current. What I found, many non-math students, especially they find this chapter very difficult because they are not in constant touch with mathematics. So they don't want to do much in this chapter or they just run away from here. But I'll tell you, the way I'm going to give you a few equations only, handful of them, just handful of them, these formulae, this mathematical relations, remember, you will see that it is no longer a difficult task for you. I can make it very simple for you, provided if you remember a few equations. So without wasting your time, start karte hain AC. So note down these formulae I'm writing for you. You must have come across this in class 11 projectile chapter, sin 2 theta equal to sin theta cos theta, where theta is an angle which is written as omega t. Theta is what? Omega t. Theta equal angular frequency or angular speed omega into time. So remember, whenever you get omega t, don't get scared of omega t. Think it is an angle given to me. It is an angle given to me. Yes, before I write this one, I just wanted to tell you one thing. Whenever you get integration, in this chapter we must know differentiation and integration, but again not much sine and cos integration and differentiation. We can only do the integration of sine function but not square function. So whenever you have sine square theta, I can change it in this way. Sin square theta equal 1 minus cos 2 theta by 2. This formula, you have to remember it. Not many, I am saying, as before I said, not many, but a few of them. How we read this one? Differentiation of sin theta with respect to theta, and differentiation of sin x with respect to x we have done in previous classes. Differentiation of sin x with respect to x is cos x. So similarly, differentiation of sin theta with respect to angle theta is cos theta. So if I apply this, on sin 4 theta, so make a very clear picture in your brain. Here I am differentiating sin theta with theta, but here I am differentiating sin 4 theta with respect to theta. So in differentiation, those who are math students, they know how to do it quickly. But those who are non-math students, don't get scared. Remember, whatever the coefficient with theta, which is 4 here, comes in numerator outside the sine function and stays inside. So it is 4 cos 4 theta. We can bring it out as well as stays in. Now theta I can replace by omega t. So if I say differentiation of sin omega t, d by dt of sin omega t, then what will happen? For example, if I say d by dt of sin omega t, so could you read it first properly? Differentiation of sin omega t with respect to t. So it is what? Omega cos omega t. This one is very important to remember. This one is very important. Sin square theta, whenever we end up with sin square theta, we can always write it as 1 minus cos 2 theta by 2. So this formula is very important for us. Similarly, the last one I am giving you, integration of sin theta d theta. Now, differential of sin is cos. So integration of sin will be minus cos. If differential of sin is cos, so integration of sin will be minus cos. Then mathematics students, they use plus integration constant c. Physics we don't require. We just remember this one. And if I give example here, similarly, suppose I want to do integration of sin omega t with respect to t. Here it was theta, which I replaced by omega t, but with respect to t I am differentiating here. So whenever you integrate sin omega t dt, omega goes in denominator. So it will be minus cos omega t by omega. That's the main thing. Differentiation of sin cos, differentiation of cos minus sin. Similarly, when we do differentiation of cos minus sin and integration of cos plus sin. So these things will come up continuously in this chapter. So I suggest you differentiation and integration of sin and cos must remember. This part again, let us focus once again. Whenever I read this term, I am reading it as differentiation of sin omega t with respect to t. So therefore, with here only t and here we have omega t. So this whatever here that comes outside as well as stays inside. So omega cos omega t. Normal students remember in simple way. Then if I say integration, if I say integration of sin omega t dt, remember integration of sin is minus cos omega t and that omega goes in denominator. Goes in denominator. So these are the 5 equations. Then I am going to give you one last equation which is very important to find average of any function. Average of any time dependent function. So what is that? Let us understand. Average. When we say average, we put a bar. So it's called f means function which is time dependent. Any function which is time dependent, we want to know average of that. Because in alternating current, as we know that it keeps on changing its magnitude continuously as well as direction periodically. So it's not constant, it's time dependent function. So therefore, in this chapter we will study in detail, and believe me, the chapter will be so simple for you. But the most important thing which I am writing now should remember. So whenever I have to find average of any function, we keep that in an average bracket like this. This is called putting a time dependent term. Suppose that expression has number of terms. So the one which depend on time we put in an average bracket. And this is written as integration 0 to t if you are integrating it from limit 1 complete cycle. 1 complete cycle means time period t. So 0 to t f t dt divided by t. Oh, it looks very scary. Yes, it looks scary for me also. But when we apply it, you will see that 1 practice, 2 practices, 3, it will be very simple for you. I am going to give an example for it. So remember, if I am doing it for complete cycle, then the limit is 0 to t. If I am doing for half cycle, limit will be t by 2 and here also t by 2. So half cycle 0 to t by 2 and here also t by 2. These equations, we will familiar with them first. Hope you have written all these equations. I am going to give you some idea about it. then we will start the chapter, because in chapter you will have only differentiation, integration, maximum. So until unless you are confident in this topic, the chapter will not be easy for you. So today, especially when we begin AC, we should know all these ABCD of chapter. So let's see that a few things. What we have written, if you apply, you can easily tell me what will be differentiation of sine 4x with respect to x. Right? Yes, I think you have done it correctly. 4 cosine of 4x. Because differentiation of sine is cos, and whatever with x given here, I have given a 4 number, constant, you can bring it out. So 4 cosine 4x. Try the second one. Differentiation of cosine 4x. Yes, correct. Differentiation of cos is minus sine. Remember, differentiation of cos is minus sine, and 4 also comes out. Three and 4, look carefully. In example 3, I am asking you integration. It is called indefinite integration because there is no limit. Integration of sine 4x with respect to x. While here I am asking integration of cos omega t with respect to t. So integration of sine is minus cos. Differentiation of sine plus cos. Integration of sine minus cos. So we will get how much? Minus cos 4x by 4. Minus cos 4x by 4. Similarly, if I ask you integration of cos, so what was differentiation of cos? Minus sine. So integration of cos is plus sine, so we will get sine omega t by omega. In integration, the coefficient with time or x goes in denominator, while in differentiation it comes in numerator. Look carefully. If you understood this and the average formula which I am going to give you idea, that is all about AC. Your whole chapter AC will be very, very simple. But provided you should know all that. So let's move to the average part. What was that horrible equation for us? It looks like nightmare. Average. Let us understand. This one is called direct current. Direct current is generally constant, the one which you get from cell, from a battery. It doesn't have frequency, it's a constant current. So DC means direct current, which we get from a cell or battery, and it has no frequency when we talk about this DC. It could be fluctuating also, that we will see later in semiconductors. So right now, which I have given here, frequency of DC is 0. This one I have drawn as alternating current, AC. AC changes its magnitude continuously, you can see. And the direction in one cycle, it changes the direction twice. Positive half and negative half. This is called one complete cycle. It is a sine function graph. Yes, sine and cos. Two graphs you have to remember. sine and cosine. And that gives me a lot of values, remember easily. Sine 180, if I ask you what is sine 180 or cos 180, sine 90, cos 90, generally normal students, they do cos 0 is according to them 0, which is not 0, is 1. And sine 0, they sometimes tell 1, which is wrong. So remember, this is a sine graph. If I have to draw a sine function graph, this is a sine graph. Because sine 0 is 0, starting from 0. Complete cycle. Look here, there are two t's here. Both have same unit, second. But this is called variable and this is called constant for a given AC. This is time period. Time period means time taken to complete one oscillation, one vibration, one revolution. So time taken to complete one oscillation, one vibration, anything which is called time period. And this is variable. Like what is the small t at this point? T by 2. Half cycle. So this is called T by 2. So a complete cycle I have divided into 4 parts. Like if you have 1 rupee, you have 25 fills, 50, 75 and 100. In Indian currency, 1 rupee means 25 paisa, 1/4 of a rupee, 50 paisa, half of a rupee, 3/4 means 75 and 1. And here, same thing I have done. Time period we have divided into 4 quarter, T by 4, T by 2, 3T by 4 and T. Now AC, when we talk about, it could be a sine graph or a cosine graph, because AC current, either we have sinusoidal function which is sine or cosine, anything. So sine and cos, any graph we can plot for it. So I'm going to give you graph for sine as well as cos. This is sine graph. But right now I'm just differentiating between AC and DC. DC has no frequency, AC has a frequency. The current which comes to our home is alternating current and which has a frequency of 50 Hertz in general. Voltage 220 volt or 240 volt in country like developing country like India and neighboring countries. Developed countries like USA and all, UK and Canada, there it is 110 volt. You might have seen some adapter written there 110 volt or 220 volt. Depending on country to country, it varies. What is the advantage of 220 volt? What is the disadvantage of 220 volt? Slowly we will see later. Why developed countries are using more energy? Because they are using 110 volt. So more energy loss. Why? All that slowly you will understand in this chapter. Which is more dangerous, 220 volt DC or 220 volt AC? Both same voltage. But DC 220 volt is more dangerous or AC 220 volt is more dangerous? That also you will understand in this chapter. But right now I am giving you alphabets of this, means ABCD of this chapter. And especially when you know this lecture will be very, very important for the upcoming lectures of this chapter. So make sure you practice them and keep them in your mind. So I am going to give you sine and cos graph with respect to t and with respect to angle omega t. So when I say omega t, it is theta, angle. Remember, omega t is nothing but angle. So we will plot two graphs. If I say theta, theta again in our mind we know theta is omega t. What is theta? Theta is nothing but angle omega t. Because in this year's sample paper, they have given a different kind of graph. Generally we practice with t, small t. They have given with respect to theta, omega t. So if they change that, our parameter will change. That's all. On x-axis now, you know, one complete cycle. When I say one complete cycle, suppose you move along a circular track. When you complete one circle, how much angle you cover? 360 degree. And 360 degrees 2 pi radian. If you don't know that, remember 180 degree equal pi radian. If you don't remember, remember this part. 180 degree means pi radian. So 360 means 2 pi radian. 90 degree means correct pi by 2 radian. Like that we remember. So this one is 2 pi. So obviously half cycle means pi. 1/4 is pi by 2 and 3 pi by 2. Yes, children. In this chapter, we will be coming across 4 different types of current. Instantaneous, peak, average, RMS. All of them are having different significance. Instantaneous current, current amplitude or peak value, maximum, which we say maximum value, average value and RMS value. Root mean square current. So first here, as you can see, I have written a general equation for AC. What is the general equation? Throughout the chapter we will take the equation like this: I equal I naught sine omega t, or I can take cos omega t. Both are called sinusoidal function. So alternating current, which we are discussing here, we can take either sine function or cosine function. So this is a graph for sine function, where I have taken I equal I naught sine omega t. I, which depends on time. This I depends on time, is increasing, getting the maximum value, then decreasing. Finally, it's increasing in another direction. Direction is changed, and then again it's going 0. That is what we have seen in AC generator. AC generator gives us AC. This is what one kind of that we have drawn it here. The maximum value is called peak value or amplitude of current. So this one is I naught. How we pronounce? I naught or I max. Depending on reader to reader, it might be different name, I max or I naught. So we are going to keep it I naught means maximum. Maximum value of AC, peak value of AC or current amplitude. That's the thing. I is called instantaneous value, the current at particular instant. So at this point, the value of I is different. At this point, value of I is different. So it's keep on changing. That means I depends on time. So I is called a function which depends on time. Back to the last equation, Ft. So a function which depends on time, here we can say instantaneous value of current depends on time. Now, I can also plot cos graph. Here I have taken theta. If I take t, small t, so then it will be time period t, t by 2, t by 4 and 3t by 4. In terms of that we will write. So that I am writing with red color. Suppose if I take here t, time, so then it will be t, t by 2, t by 4 and 3t by 4. Like that we give the naming. This is again peak value but negative, so minus I naught. Obviously it is negative because below origin, negative I direction. This graph for sine function, same thing I can draw for cos. Cos 0 is 1. So therefore it won't start from 0, it will start from top. So cos 0 starts from top. So this one is for cos graph. The equation is I naught cos omega t. I equal I naught cos omega t. Here I am plotting a graph with respect to what on x-axis? Omega t. On x-axis we have taken omega t. So therefore it is cosine graph. And if someone asks you plot a graph of minus cos, no need of taking tension. If I ask you minus cos graph or someone asks you minus cos omega t, mirror image. Mirror image means you will start from down, goes up, that's all. This point will come here reflected, right? So let's draw the mirror image of it. So that's the cos graph. So remember, minus cos graph is minus 1 starting from minus 1. So here I naught is same current amplitude or peak value. I instantaneous value, and it's a cosine graph. When we see the graph again, we will revise this part. But right now you understood this, how to plot. And then if I say here t only, instead of omega t, if I say t, then this is complete time. If I say here parameter t, t is the time period. Small t. Small t is the time, which is keep on changing. So then this point is called t, t by 2, t by 4 and 3t by 4. So you should be able to read on x-axis, are we taking time as a variable or are we taking angle as a variable, which is omega t or theta. This is what you have to remember. So we have learned a few things today in this formula sheet and the plotting a graph. Now we will start two different currents which I spoke to you, average value of AC. How to get average value of this current I? Current I, which is instantaneous value, depends on time. So if I want to know the average, for complete cycle average will be 0 because plus half and minus half gives me 0. Whether it's a sine function or cos function. But how to prove mathematically? That is the first question which comes in CBSE. Prove that mathematically average value of AC is 0. So I have to prove that part, which let us see. Prove that average value of AC over a complete cycle is 0. So what we have to prove? Average value of AC over a complete cycle is 0. Question is clear? For complete cycle, average value of AC is 0. And now remember, just for the symmetry, because they don't give you which current you have to take. So you can take sine or cos anyone. Always try to take, if not given, sine function. So I am taken I equal I naught sine omega t. What I have taken? I equal I naught sine omega t, where I is instantaneous value, time dependent current, I naught is current amplitude or maximum value, peak value. This current depends on time. Look here. So this current depends on time. In the right hand side, I naught is constant for a given AC, maximum value is constant, sine function, this is time dependent function. So now the last equation which I gave you for average. So this current is a time dependent current. You can write in bracket small t, later you can avoid it. So this is called instantaneous value which depends on time. So I bar means average. You have to prove that average value. I naught, only this function sine omega t depends on time, so I kept in a special bracket. I put it in a special bracket because this one depends on time. I naught doesn't depend on time, so outside that. So the average bracket ft is clear. Now the formula. Since we are doing it for a complete cycle means 0 to t. So it will be I naught integration 0 to t, function is sine omega t given to us, dt divided by t. Again understand this part, because this is what which is very important. Integration ft dt, there we have written ft is a function which depends on time. So it was the sine term which was depending on time t. So I kept in the integration 0 to t sine omega t dt by t. If I want to prove for half cycle, 0 to t by 2, t by 2 limit, and that will not be 0, because half cycle it is positive or full negative or full positive, depending which half we are talking about. So right now I am proving for the complete cycle. So complete cycle I am going to get 0 mathematically. So let us see here. Integration of sine, quick, integration of sine. Cos or minus cos? Minus cos. Differential of sine, cos. Integration of sine, minus cos. Limit 0 to t. Limit 0 to t. Upper limit minus lower limit you have learned before. Even if you don't know, I am going to tell you how to apply. This omega, you can bring it outside. So it will become minus I naught by omega t. I took minus also outside. I took the minus also outside. So what is left? Cos omega t 0 to t. Now, maybe many of you may not be knowing how to apply limits. What is the rule for limit? So upper limit, you replace this small t by upper limit t. Then minus, you have to replace this t with lower limit. Upper limit minus lower limit, that is the rule. So I am going to apply it here. Cos omega. Omega angular frequency or angular speed, you know 2 pi by t or 2 pi nu. You have learned before. Omega is 2 pi into frequency or 2 pi by time period. So I am writing omega is 2 pi by t. And this t, look here, this t replaced by capital T. So what will you get? Upper limit t. Small t replaced by t. Minus cos, this is again omega. Lower limit I am applying. So what is the lower limit? 0. So replace by 0, you will get into 0, which is 0. 0 multiplied by anything is 0. So now here, this t get cancelled. What is left? Cos 2 pi. Minus I naught by omega t cos 2 pi minus cos 0. How much is cos 2 pi? If you see the graph which I have given you, cos 2 pi is 1. Remember, sine and cos, remember children, sine and cos, their maximum values are plus 1 and minimum value is minus 1. They oscillate between these two values, plus 1, minus 1, plus 1, minus 1. Any sine value you take any angle, not even 0 to 90, sine 170, sine 1,03,500 degree. All these angles will fall between plus 1 to minus 1. So maximum plus 1, minimum minus 1. Cos 2 pi is 1. If you see the graph, you come to know cos 2 pi is what? 1. And cos 0 is also 1. So 1 minus 1 gives me 0. 1 minus 1 gives me what? 0. So like this, 2 marker comes in your board exam. Prove that average value of AC for a complete cycle is 0. For that you should remember cos 0 is 1, cos pi is minus 1 and cos 2 pi is plus 1. See the graph. Plus 1, minus 1. This is the graph for cos. This is the graph for cos. So here this angle is called 2 pi. So what is the value at 2 pi? Plus 1. What is the value at 2 pi? Plus 1. What is the value at 0? Plus 1. What is the value at pi? Minus 1. This is pi here. If I take angle here theta, so what is the value at pi? Minus 1. So it oscillates between plus 1 and minus 1. So So if you don't remember what is cos pi, what is cos 2 pi, plot a graph. Graph will give you clear picture. What is cos pi? Minus 1. Cos pi minus 1. Cos 2 pi plus 1. Cos 0 plus 1. Cos 90 0. Because cos 90 is this one. Pi by 2. Cos pi by 2 is 0. So therefore cos and sine graph, if you remember your values of 90, 180, 270, 360 will be very easy to keep in our brain. Otherwise you have to memorize them. Why to memorize? If I know the sine graph and cos graph, I could easily figure it out. What will be the sine pi, what will be sine pi by 2, what will be cos 3 pi by 2 in a simple way. So today what we have seen lot of formulas. To begin with AC, these are very important. So we have come across 3 different current: instantaneous, then we came across peak value, maximum value or amplitude of current I0, and third, average value. Fourth one we will see in the next video, root mean square, RMS value of AC. With these, if you revise it properly, children, the chapter will be very, very simple for you. And I hope I will make it very simple in such a way that you need not to memorize. You need only understand the basic formula, keep in your mind. Okay? That's all for today. See you in next class. Take care. Bye-bye. Thank you.